All right, if you're writing in C#, you've got a choice you have to make all the time. Should this new type I'm creating be a class, or should it be a struct? Now, it might seem like a small detail, but believe me, getting this wrong can really mess with your app's performance and create some nasty bugs. So today we're going to break it all down and make sure you get it right every single time.
So here's our roadmap. First, we'll tackle the big picture idea, blueprints versus building blocks. Then, we'll do a deep dive into classes and how they work with references. After that, we'll look at structs and their world of values. We'll put them side by side for a head-to-head comparison, and wrap it all up with a practical guide so you know exactly which one to pick.
Okay, first things first, blueprints versus building blocks. Before we even look at a single line of code, we've got to wrap our heads around the core philosophy here. This isn't just about syntax, It's about how you want to think about and structure your data from the ground up.
And really, it all comes down to this question, doesn't it? When you're sitting there ready to model some data, what's the right tool for the job? You've got these two fundamental options in your C# toolbox, and knowing which one to grab is what separates good code from great, efficient code. So let's use a metaphor that's going to stick with us. Think of a class as an architect's blueprint for a house. It describes the house in perfect detail, how many rooms, where the windows go, but it's not the house itself. A struct, on the other hand, is like a single solid brick. It's not a plan, it is the thing, a self-contained building block.
So let's zoom in on classes first. And remember that blueprint idea? Because it's key. A class defines what an object should be, but it isn't the actual object, it's the template. And this leads to the most important concept about classes. They are reference types. What does that mean? Well, when you create a variable for a class, that variable doesn't actually hold the object's data. Nope. Instead, it holds a little pointer, an address, that tells the system, hey, the real object, it's over there, in a place called the managed heap.
Let's watch this in action. In step 1, we declare myClassMC. At this point, MC is just an empty signpost, pointing to absolutely nothing. It's null. Then, in step 2, we use the new keyword. This actually builds our object in memory, on the heap, and now MC holds the address to that object. Now here's the critical part, step 3. When we say myClassMC2 equals MC, we are not making a new object. We're just making a copy of the address. So now, both MC and MC2 are pointing to the exact same object.
So let's recap what makes a class a class. First, it's a blueprint. Second, its objects live on that managed heap we talked about. Third, when you're done with an object, something called the garbage collector comes along and cleans up that memory for you. And finally, and this is a big one, classes fully support inheritance, which lets you build those powerful object hierarchies.
Okay, now let's flip the coin and talk about structs. If a class is the blueprint, the struct is the actual tangible building block. It's a whole different way of thinking.
See, structs are value types, which is the complete opposite of a reference type. A struct variable doesn't hold a pointer or an address to somewhere else, it holds the actual data right then and there. The variable is the value. There's no middleman.
And this has a massive consequence. Because the variable is the data, anytime you assign a struct to another variable or pass it to a method, the system makes a complete, independent copy of the whole thing. This is what we call value semantics.
And this table just lays it all out perfectly. Look at the class example. MC2 equals MC means you have two variables pointing to one object. If you change something using MC2, you'll see that change when you look through MC. But now look at the struct. When you do chords2 equals chords1, you create a brand new, totally separate copy. You could change chords2 all day long, and chords1 wouldn't even notice. They are completely independent.
All right, enough of the individual profiles. It's time for the main event. Let's get these two in the ring for a proper class versus struct showdown. This is where the differences really pop.
Round 1, the core semantics. As we've seen, a class is all about reference semantics. It passes around pointers. A struct, on the other hand, is all about value semantics. It passes around copies of the actual data. This is, without a doubt, the single biggest difference between them.
Next round, inheritance. And this is a total knockout for classes. They fully support inheritance, which lets you build complex and reusable object models. A struct? Nope. It's a sealed deal. It can't inherit from anything, and nothing can inherit from it. Now, it is worth pointing out that both of them can implement interfaces, which is a way of promising they have certain methods.
And here it is, the final summary. We've hit on the type, assignment, and inheritance, but notice a few other key differences. Memory. Classes live on the heap,
Structs usually live on the stack, which is often faster to access. Default value. An uninitialized class variable is null, meaning it points to nothing. An uninitialized struct is just a block of memory with all its fields set to 0. All of this points to their typical uses, which brings us to our final and most important section.
So, after all that theory, how do you actually make the call in your day-to-day coding? When do you type class, and when do you type struct? Let's get practical.
So when is a struct the right move? Well, Microsoft actually gives us a pretty handy checklist. Just ask yourself these questions. Is the thing I'm making small and mostly just data? Does it have very few methods, if any? Does it logically represent a single value, like a color or a point on a graph? And finally, is it immutable, meaning once you create it, it never changes? If you're nodding your head yes to these, a struct is probably your best bet.
And what about the other side? Well, this quote from the official docs really says it all. If you're focused on the behavior of a type, consider defining a class. It's that simple. If what your type does is more important than the data it holds, if it has complex logic and responsibilities, you should be using a class. Honestly, for most things you build, a class is the default go-to choice.
And there we have it. The choice between a class and a struct isn't just a minor detail. It's a fundamental design decision that affects performance, memory, and how your code behaves. So the next time you're about to write public class, just take a second, pause, and ask yourself, wait, should this actually be a struct? Thinking about that one question will make you a better C# developer.